Okay, so these problems are about projectile motion or quadratic modeling because we're going to have an object that's either thrown into the air or dropped from a particular height, and we're going to find either the height the object reaches or perhaps how long it takes for the object to hit the ground. So whenever we do these kind of problems, we have to know this equation. So the height with respect to time, which we write h of t, okay, equals negative 16t squared. So negative 16 is the effect that gravity has here on Earth, okay? So, and this is in feet per second squared, okay? So, because on Earth, every object is affected by the force of gravity. That's why when we throw something in the air, it doesn't just keep going up in the space forever. Gravity eventually catches up to the object and starts to bring it back down. So, gravity in this problem is negative 16. And again, that's what it is on Earth. And this is the unit that we use for feet per second. Okay? Then, we add, wrong color, we add the initial velocity. Okay? So that's what the v of 0 stands for. This is initial velocity. Meaning, how fast was the object traveling when it started moving? Typically, those are things like if I pitch a baseball, if I throw a football, if I launch a firework into the sky. Okay? The initial velocity would be, it starts, when we start to measure this object, it's already traveling at a certain velocity. Okay? And then lastly, is h of 0. Okay? And h of 0 stands for initial height. Meaning, before time begins, or before I'm about to throw something, does it start at a certain height? Because gravity will have an effect on an object only when it's above the ground, right? Because gravity pushes it towards the ground, but once it hits the ground, gravity doesn't have an effect, well, per se. It does, because that's how the object stays on the ground. But anyway, so h of 0 is the initial height. So we need this function. And this is a quadratic function, meaning it will produce a parabola. Okay? And we will use those properties to figure out some of these things. Okay. So for number 1, it says, some fireworks are fired vertically into the air from the ground. Okay. So from the ground is an important thing. I'll talk about that in a moment. And initial velocity, so initial velocity of 80 feet per second. Okay. Find the highest point reached by the firework just as it explodes. Okay? So if I could model this problem, okay? So remember, it says it was shot straight up in the air. So most students think, okay, we'll make the y-axis h and the x-axis t. Okay? Most students think, oh, it's launched from the ground, so it's just going to go up and then come down. And it's going to be a straight line. But in my graph, remember, time has to increase, right? As the height goes up, time has gone by, right? It goes up in the air for 1 second, 2 seconds, 3 seconds. So it actually is not going to be a straight up and down line, because these kind of graphs, they don't represent the object flying through the air. Okay? So whenever we do these types of graphs or work with this quadratic model equation, we're not talking about the object. We're not talking about the way that it's traveling. We're talking about how high the object is over time. Okay? And then most students say, okay, well, doesn't that mean then it's doing this? Right? Because it starts at the ground, and then as time is going, it gets higher and higher. But think about it. If I'm shooting a firework in the air, does the firework just keep going the same speed the entire time? No. Just like anything you throw in the air, right? It starts fast, but then it starts to slow down, and then when it reaches the top, it actually starts coming down again, right? So it may start fast, but it actually slows down until it gets to the top and then comes back down. So actually what we're working with here is a parabola. Right? So the object is going to go fast, and then it's going to curve a little bit, and then start to come back down the other way. Okay? So this is the model that we're working with here. Okay? So it's a parabola. Now, the question asks, find the highest point reached by the firework. Well, isn't that this right here? The that point on the graph, right? That's the highest it will reach. And guess what that is on a parabola? That's the vertex. Okay? So, we want to find the vertex. The vertex is super important for this problem. Okay? So, we use our equation that I wrote up at the top there, and now we have to find the vertex, because we're going to find the highest point. Now, do we want to find the height, or do we want to find the time, is the question. We want to find the height. Okay, so keep that in mind. The highest point, so we want the height. Okay? But how do we find the vertex of a parabola? Well, hopefully, you're looking at this saying, well, I know that the vertex is exactly in the middle of my parabola. And do you know what else is in the middle of my parabola? My axis of symmetry. Yes. Okay. My axis of symmetry is in the middle. And to find that, of course, it's x equals negative b over 2a. Okay. So, I have to use the axis of symmetry formula to find where the middle of the graph is. Okay. So, let's plug in our function here, because we haven't done that yet. So, h of t equals negative 16t squared. Okay? Now, it says v of 0. Did it give us an initial velocity? It did, 80 feet per second. So, I'm going to put 80t plus an initial height. Did it give me an initial height? Well, I'm looking at the information here. It says from the ground. So, isn't the ground 0 feet, like if it's on the ground? So I could put plus 0 if I wanted to. But do I have to put plus 0? No, I don't. Okay. So let's go ahead and try to find the axis of symmetry based on this info. All right, now, just with any quadratic equation, I want to try to make this the easiest I can. I want to try to make the problem, I want to try to take out the greatest common factor and make this as easy as I can. Well, wait a second. Can I take out perhaps a 16 from both, right? Because you might look at that and say, okay, I know 2 can go in there. But what's the biggest thing I can take out? I can actually take out a 16. Okay? And if I take out a 16, I'm left with negative t squared plus 5. Okay? Now, you might be saying, oh, excuse me, so that's 5t. All right? Now, you could do that, okay? And there's some of you like, well, wait, why can't I take out a t? Because I need it to stay in standard form. Meaning, I don't want to pull out a variable as well, because if I were solving, meaning I needed to find the x-intercepts, I mean, I could do that. I could pull out a t and then say that HP is equal to 0. But I don't want to do that. I only need to find the axis of symmetry. Okay? So I could try to make this as small as I can. Now, you could have used the original. You could have used negative 16t squared plus 80. I'll show you how it works for both. Okay? But for the easier one that I just made, this makes it real easy. Watch this. Because it becomes negative 5, that's negative b, over 2 times negative 1. Which is negative 5 over negative 2, which equals 5 halves, or 2.5. Okay? Again, I could do the same thing with the top equation. Okay? So I could plug in negative 80 over 2 times negative 16, which would give me negative 80 over negative 32. And negative 80 divided by negative 32 gives you 2.5. Okay? So they both work out the same way, but if you can make it simpler, I always recommend making it simpler. Okay? So that is x. X is 2.5. But remember, in this equation, x is time, correct? X is the time axis. And we wanted to know the highest point, meaning we need the height. So how do you think I can find the height given the time? Well, can't I plug in that time to find out how high the object is? Yes, I can. What I'm going to do, I'm going to plug in this 2.5 into the equation. Okay? I'm going to plug it in, and I'm going to find what the height of the object is at 2.5 seconds. Because I know what time it gets to the highest point, but now I need to find what the height is at the highest point. Okay? And I'm going to continue the work down below number 2 here. I know it's going to be kind of confusing, but I just told you, so hope you're paying attention. Okay, so h of 2.5, because I'm plugging in 2.5, equals, we'll use the bottom one here. So 16 times negative 2 point, whoops, it's actually negative 2.5 squared. That is important, by the way, that I did it that way, 2.5. Okay. So 2.5 squared is 6.25. Then you apply the negative. The negative doesn't get applied to the 2.5 in the beginning. Otherwise, you'll get the wrong answer. Remember, you do exponents first, then apply the negative. Okay? So I have negative 6.25 plus 2.5 times 5 gives me 12.5. So negative 6.25 plus 12.25 actually equals 6.25. And 6.25 times 16 equals 100. But 100 what is the question? Well, I know that 2.5 seconds, but at 100 feet is the highest point the firework will reach. So here, it's at 100 feet. Okay? So typically, if you have to find the height, the first thing you have to find is the time, then plug that in to find the height. Okay? But there might be times where you might want you to ask you what the time is. So just make sure that you pay attention to the question. So that's number 1. I'll go do number 2 in a second video.